Imagine you are drifting in space. Ahead of you hangs an immense black sphere ringed by a disk of burning light. You have just found a black hole. You try to pull away. It is already too late. Its gravity is drawing you in, and it will not let go. So what would you actually see? How long could you survive? And what, if anything, is on the other side? A black hole is not really a hole. It is a region of space where an enormous amount of matter has been crushed into an extremely small volume. Most stellar black holes are born when a massive star reaches the end of its life. Once it has burned through its fuel, the core collapses under its own gravity. If the star is heavy enough, nothing can stop that collapse. What forms is an object so dense that its escape velocity exceeds the speed of light, which means nothing can climb back out, not even light itself. That is why a black hole appears completely black. But around it, matter can gather into an accretion disk, a vast whirlpool of gas and dust, heated to millions of degrees. That disk can be one of the brightest objects in the universe. As you get closer, something strange begins to happen. The starlight starts to bend. The black hole's gravity curves space-time so sharply that light rays follow paths they never would elsewhere. You might see the same star more than once, or catch light coming from behind the black hole, wrapped around it like a cosmic lens. Then you reach an invisible boundary, the event horizon. It is not a solid surface. It is simply the point beyond which there is no way back. Once you cross it, every possible path leads inward. Even traveling at the speed of light, you could not escape. To someone watching your fall from a distant ship, your motion would slow. As you neared the horizon, your image would appear to freeze. The light from your body would shift further and further toward red, then fade from view. To that observer, you would never quite finish crossing. Your image would hang at the surface, and then it would be gone. But from where you are, it is nothing like that. You keep falling normally, and if the black hole is massive enough, you could cross the event horizon without noticing anything at all. No barrier, no explosion, no signal. You would simply have passed the point of no return. Your real problem would be tidal forces. The part of your body nearest the black hole feels a far stronger pull than the part furthest away. Your feet fall faster than your head. Your body begins to stretch lengthwise and squeeze inward from the sides. The phenomenon has a surprisingly official name: Spaghettification. Around a small stellar black hole, those forces would be violent enough to tear you apart before you ever reach the horizon. But around a supermassive one, like the black hole at the center of our galaxy, the tidal forces at the horizon are gentler. You could, in theory, cross it alive for a short while. The deeper you fell, the more brutal the difference in gravity would become. Your cells, then your molecules, then your atoms would be pulled apart. Once inside, there is no way left to reach the outside. Every signal you tried to send would stay trapped with you. According to general relativity, you would keep falling toward a region called the singularity, a point where matter is compressed to a density that is, in theory, infinite. And there, the equations we have stop working. General relativity describes massive objects beautifully. Quantum mechanics describes the microscopic world beautifully. But at the heart of a black hole, the two theories contradict each other. So we do not actually know what is at the center. The singularity may be real, or it may be replaced by some quantum structure we have not imagined yet. Some hypotheses suggest Black holes could be linked to other regions of the universe by tunnels, wormholes. They might even, in theory, lead to another universe entirely. But nothing today shows that such passages exist. And even if they did, the forces inside a black hole would almost certainly make the crossing impossible. So, black holes are not necessarily cosmic doorways. What they mark is the limit of our understanding of space, of time. Falling into a black hole would be a journey with no return. To anyone watching, you would slow, redden, and vanish. To you, the fall would simply continue into the unknown. Your body would be destroyed by tidal forces, and everything that made you would appear to stay locked behind the horizon. But the most interesting question is still open. What is really at the heart of a black hole? A singularity? A passage into somewhere else? Or a piece of physics we are still unable to imagine? For now, the universe keeps its own secret,